All right, this is Algebra 2. We're going over Pretest 9. I'm going to go ahead and write the problems here. Here we go. There were 10 questions, right? The 10th question was a bunch of questions, though, so maybe you'll consider this more. How do you do problem number 1? Y equals cosine of x. So this is just a parent function, so if I were to graph this, and I have really cool tools at my disposal, so I have straight lines, very nice, I know. So cosine starts at a maximum. Negative cosine starts at a minimum, which we're not doing. Sine, both positive and negative, start at a midline. So we know we start at the maximum. The general shape of a cosine wave, ooh, I could do a little better. I should go down a little bit more. Oh my gosh. Please, Mr. Sindel, one of these will be right. That one looks nice. Okay. There are important points. I'm marking all of the points that are on the midline, which happens to be the x-axis in this case. I'm marking all the maximums and the minimums. So there should be 5 points on every single one of these graphs. So this is something that you should just have in your notes. You have an x-coordinate that starts at 0. The height, the y-coordinate, is 1. And then the entire period is 2 pi. So if I come over here, a total distance of 2 pi, that means my x-coordinate is now 2 pi, because 0 plus 2 pi is 2 pi. And the height is still 1. The y-coordinate is 1. You'll notice that the y-coordinate flips down here to -1. Halfway in between 0 and 2 pi is pi. And then the harder points to remember are the halfway in between 0 and pi. Half of pi is half of pi, or pi over 2. So that's pi over 2 comma 0, because you're not going up or down. And then that means from 0 to pi over 2 is a quarter of the period. A quarter of the period, a quarter of the period, and then another quarter of the period means I'm adding pi over 2 to pi. And if you don't know how to do that off to the side, I'll say pi plus pi over 2 is going to be 2 pi over 2 if I multiply this top and bottom here by 2 over 2, plus that original pi over 2. That's going to give us 3 pi over 2. So this x-coordinate is 3 pi over 2, comma 0. And there's the graph. All you have to have is 5 points with the x and y coordinates. How do we do problem number 2? I'm going to be super lazy about this and just go ahead and look at the picture. -9 cosine of x. Y equals -9 cosine of x plus 1. All right, and we're trying to graph this. You're either going forwards or backwards. This is the case where you're going forwards. We have a graph. So let's go ahead and graph our y-axis, our x-axis. Let's go ahead and say that this doesn't represent the x-axis. Let's go ahead and say no. Scribble that out. We don't want that the x-axis. We want that to be the midline, this midline of 1. I'll take some notes on here as well. So the 1 over here, this affects the midline. This 9 is kind of the amplitude. I say kind of because you can't really have a negative amplitude. The negative does flip the graph. So look at our previous problem. This was cosine. It started at 0, 1, but because we have a negative out here, it's going to, instead of starting at a maximum, start at a minimum. So it's going to start down here. And there's no phase shift. There's no period, weird things happening here. It's just simply a flip. So if this line here represents the equation y is equal to 1, it's at a height of 1 because of the midline. And I go down 9. I'm already at 1. I go down 9. I'm now at -8. So the y-coordinate here is -8. So I'll do something comma -8. What is that something? Well, look over here. The original x-coordinate was 0. Did we move left or right? No. So it's still 0. If there's phase shift, that would have been a little bit different. And then let's go ahead and sketch this out. So it's going to be a cosine. It's going to come up and then back down. I know, not the prettiest drawing, but I'm going kind of fast. All the points that we care about, anything on the midline, a maximum, the other minimum, we have all these points. All right, so our period is still 2 pi. Our x-coordinates do not change for this problem. As I've said multiple times now, it's going to be 2 pi, and the same y-coordinate, -8. If I have a minimum that's at -8, all the minimums are going to be at -8. What about the maximum? The maximum over here, it used to be the minimum, used to be pi, and it is still pi. That x-coordinate has not changed. What about the y-coordinate? The y-coordinate, it started at y equals 1, this midline, and it went up a total distance of 9. 9 plus 1 is 10. We're doing well. Again, our x-coordinates don't change for our midline. It's going to be pi over 2 and 3 pi over 2. So this is still going to be pi over 2 and 3 pi over 2, comma, And what is the height here? Well, the height is 1. It is on the midline, so it's just 1, comma 1. And we're done. On to number 3. Problem number 3 is we have a midline. The midline, or a point on the midline. The point on the midline is 0, 5. We have a point on the maximum. That is at pi over 2, 7. Pi over 2, 7. Let's go ahead and graph those, and then we'll discover some things by adding points to our graph. So there's my y-axis, there's my midline. I'm not going to call that my x-axis. So this point is on the midline, and it moves left and right a total distance of 0. It is on this y-axis, but it's not at a height of 0. It's at a height of 5. I'm just going to say that this line represents my midline. This is the y equals 5. This is the midline. So from here, I also have a maximum. Maximum means I'm above, not below. This is a minimum. So I'm going to come up here and say, sure, that point represents my maximum. And that is pi over 2, 7. I'm just going to do an arrow because I'm nice and lazy. And then we go ahead and graph. I can make a better line. It's so embarrassing. Mr. Sindel, you've been doing this for how long and you don't know how to graph very well? Okay, good enough. Okay, those are all the important points. I should relabel this as 0, 5 over here. Notice that the midline is 5, which means all of these y-coordinates are 5. I don't really care too much about labeling each of these points. It's very tedious to do. I want the equation. That's the whole point. What is the equation that represents these functions? And we do make this assumption that the midline and maximum are as close together on the x-axis as possible. You don't like skip some. So over here, we want to figure out what is the x and y coordinate. I don't really care about the y coordinate. The y coordinate is 5. It's on the midline. What is the x coordinate, though, of this final end of the period? Because again, this once I go up to the max, down through the minimum, and then back up, I have now completed one period. So I can say that this distance right here, whatever that distance is the period. So it's really important to know what is that number. So notice that from a midline to a maximum, this distance right here is a quarter of the period, or 1/4 of p. So what is that distance? That distance is pi over 2 minus 0. You subtract those two to find distance. So I can say in my notes that a quarter of our period is pi over 2 minus 0, which is just pi over 2. A little bit pedantic to say minus 0, but it's always this x-coordinate minus that x-coordinate. That's what I want you to take away. So if I know that quarter of a period, I can just keep adding on another quarter period, another quarter period, another quarter period, until I get to this number that I'm after. So add pi over 2, add another pi over 2, add another pi over 2, add another pi over 2, and you'd be like, wait, isn't that the same thing as up here? And you're right. It's pi over 2, pi, 3 pi over 2, and 2 pi. You might have just recognized it. You can add them up and check if you want to be sure. But the period, nothing has happened. So the period is still the same, which means when I'm making my equation, which I'll write down here, y equals whatever my amplitude, blah, blah, blah. By the way, let me do the general equation. The general equation is a times, I don't know, it doesn't matter if it's sine or cosine. I'm just going to randomly choose sine. Sine of a, I already used a, b times x plus c plus d. That's the general form that we should be matching. And what we've just discovered right here is the period does not change, which means this b, there isn't one. There is no number right there. Also, there's no phase shift, this c right here, there's no phase shift because I'm starting on this y-axis. If I start on the y-axis, you don't need a phase shift, which means I'm only after two variables for this problem. First of all, what is the amplitude? What is this distance right here? Well, that distance, I started at 5 and I moved up to 7. I can just say my amplitude here is 7 minus that 5. Distance is always a subtraction problem. 7 minus 5 is 2, which means this distance is 2. So I don't know if this a value is 2 or negative 2. I do know that it's one of those because this distance is 2. So let me go ahead and write down my final answer. Y is equal to, it could be plus, it could be minus. We'll just leave it as 2 for now. 2 sine of x. There's no other numbers in here. I told you b and c aren't there. And then finally I have to add my midline. And we know the midline here is 5. So I can say just plus 5. The last question is this a negative 2 or a positive 2? And answer that, you need to know the difference between what does positive sign look like and what does negative sign look like. Positive sign looks like this, where it first goes up. Negative sign looks like this, where it first goes down. Both of them start on the midline. Let's say that that was like the midline. Both of them start on the midline. The only difference is one starts going up, one starts going down. Ours starts by going up. Therefore, we have a positive sign. Therefore, this is a positive 2. I don't have to write that plus. If it's nothing, you assume it's positive. And there is our final answer. I'll box it because there's a lot of math on here. Usually when you have a graph, you don't need to box the graph because you're not going to draw multiple graphs. And we're done. That's problem number 3. I'm feeling like going on another piece of paper. I don't want to have to come back up to the top right. So let's go ahead and add a page here. And let's just zoom into one page. All right, we're on problem number 4. I know this is kind of a long video. You can skip around, use whatever piece of the video you'd like. Problem number 4, sine of x minus pi. Y equals sine of x minus pi. We only have one thing happening. We have no amplitude that's being adjusted. We have no period that's being adjusted. There would have been a number in front of the x. And we have no midline. The only thing that's happening is this minus pi. This is called phase shift. Phase shift. And the way that that works is you move left or right the opposite of whatever is here. So if this is minus pi, really all the x coordinates you add pi to. So again, just as a way to remind you what the parent function is, you hopefully have this in your notes. The parent function of just y equals sine of x, no phase shift, looks like this. And it's a very quick sketch, so bear with me. It looks like this, where these x and y coordinates are all the same as the parent function, which is 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, -1, and finally 2 pi, 0. That is our parent function, but everything is going to have an x coordinate plus pi. You always do the opposite of whatever's in here. I've explained that before. I don't want to go into it right now. This is already a long enough video. So each of these x coordinates, I now say plus pi. So our actual answer here, since I'm using the full page, I can use this space over here. Our actual answer here, I don't know why I stopped drawing straight lines, but whatever. I'm going to go with it. I just shifted over a little bit. So now looks like that. Look at this space that I've jumped over. This has been moved over plus pi. So this is no longer 0, 0. It's pi, 0. I added pi to the x coordinate. Yep, I'll answer that in a sec. And I add pi to pi over 2, and I've done that before, but you can look at it later, or look at it from before in the video. That's 3 pi over 2. Add another pi over 2, you get 2 pi. 2 pi, I forgot the x coordinate, or the y coordinates, 1, 2 pi, 0. Add another pi over 2, because the period hasn't changed. It's still pi over 2 for a quarter of the period. I can write it up here. A quarter of the period is still pi over 2 because it hasn't changed. And I get 3 pi, oh, I did 3 pi over 2, 5 pi over 2. It's one of those odd numbers, right? 5 pi over 2, -1. And finally, you come back to the end of the period, right? And that's going to be 3 pi, 0. And there is our final answer. Let's move on to number 5. Number 5, what do we have? Number 5, graph, oh, that one's going to be fun. You have y equals cosine of, in parentheses, we have 1/6 x plus pi over 3, plus pi over 3. It's kind of like number 4. You have phase shift happening, but also we're affecting the period. This number in front of x is modulating the period. By what, though? Whenever you have a problem that has both phase shift and, sorry, that's not phase shift, both something affecting the period and phase shift, you need to rewrite it in the general form. And if you remember the general form up here, it has b factored out. So this is how you will factor out that 1/6. You're going to say, our new equation is y equals cosine. You have to factor out the 1/6. It's whatever the number is in front of x that you factor out, because you want x by itself. Look, now it's by itself on the inside of this new set of parentheses. But when we factor out a 1/6, we're saying this number divided by 1/6, and this number, this pi over 3, that has to be divided by 1/6. Each of these two numbers were divided by 1/6. So this is my way of showing my work. Sometimes I just jump right to the answer. So what is that? So let me write my final equation that I'm going to be graphing. I have 1/6 x plus that thing. I have a fraction divided by a fraction. That means I have pi over 3 divided by 1/6. I'm going to keep it, change it, flip it. This is going to turn into pi over 3 times 6 over 1. I'll do it the long way, just in case. So 6 times pi is 6 pi over 3. 3 times 1 is 3. And then 6 divided by 3 is 2. So this is going to be 2 pi. The quicker way would have just been to cross cancel and say, 6 divided by 3, and that's 1 and 2. Cross cancel, 2 times pi is 2 pi. It's about the same amount of work, but this is showing my work a little bit more rigorously. Anyway, the 2 pi, that's what should go right here, right? I just simplify the fraction divided by fraction. So I have plus 2 pi. Perfect. So now, end the parentheses, there we go. Now I can graph. But to graph, I need to know a few things. Yes, I'm going to be going left by 2 pi. Notice that it's left because it's the opposite sign right here. But this thing affects the period. By how much, Mr. Sindel? Well, the answer here is by a formula. The period is equal to 2 pi divided by whatever this number is. I'm going to call that number. So it's 2 pi divided by number. So in our case, this is going to, I'm going to do an arrow, it's not equal to. That means for us, we're going to have 2 pi divided by that number, 2 pi divided by 1/6. And again, I have an embedded fraction, so this is really the same thing as 2 pi divided by 1/6, or 2 pi over 1 divided by 1/6. And I'm going to keep it, change it, flip it. This is 2 pi over 1, keep it, change it, flip it. And I don't know randomly why I decided to change to blue. This should all be in green, so I can just keep track of my work a little bit better. This is equal to 12 pi over 1. You just multiply the tops, 12 pi, multiply the bottom, 1, and that's just 12 pi. I forgot the 1. 12 pi. Okay, that is the period. Remember, this is p. I can rewrite the p. That is our period, which is awesome. So we know the period, and we know to shift left by 2 pi. Just with those two facts alone, we should be able to make an okay graph. So let's get this set up. So normally, we start on this y-axis somewhere. Maybe I would put it right there. Maybe I put it there, there. We have a positive cosine. So typically, I should start right here. But this says go left 2 pi from that original 0, 1 coordinate. That was the parent function. You can look at number 1 up above. But I'm shifting that point left by 2 pi. So my point is actually going to be right here. And that has coordinates, well, I went left, so negative 2 pi. And my height has not changed. There's no amplitude happening out in front of cosine. This is still 1. All right. So we have that first point, and we know that this is going to go do something like that. And I know that the entire period here, this entire distance is 12 pi. This entire distance is 12 pi. So if I start at negative 2 pi, I move 12 pi to the right. Where am I now? Well, negative 2 pi, and you just add on that distance plus 12 pi. You can do it off to the side if you don't believe me. Negative 2 pi plus 12 pi. How much am I now? I'm at 10 pi. So this x-coordinate is 10 pi, comma something. And the height hasn't changed. The height is still 1. The y-coordinate is still 1. Perfect. I have 2 of the 5 points. Well, from here on out, it's kind of a simple ordeal. The y-coordinate down here should be negative 1. I haven't changed anything for the amplitude. What about the x-coordinate? You might be thinking, you just take 10 pi and you divide it by 2 because it's half, Mr. Sindel. You're wrong. You don't divide the n-coordinate by 2. You divide the entire period by 2. 12 pi divided by 2 is half the period. So I can say half the period is half of 12 pi. Which is 6 pi. So what have I discovered? Half the period is 6 pi. So half the period is 6 pi. That means I'm going, this distance right here is 6 pi. That's just 6 like that. So 6 pi from negative 2 pi is 4 pi. So I have 4 pi, comma, negative 1. And you do the same thing again to get a quarter of the period. What is that x-coordinate? What is that x-coordinate? I know the y-coordinate is the midline, which plus 0, I guess 0 is the midline. The x-axis is the midline. You can say something, comma, 0. This is going to also be something, comma, 0. But what is that something? It's a quarter of a pi from negative 2 pi. How do you find a quarter of a pi? The same way we found half of pi. You do a quarter of pi is equal to, did I say pi? A quarter of the period. A quarter of the period, well, the normal period was 12 pi. So if I want a quarter of 12 pi, I say a quarter of 12 pi. And then 12 divided by 4 is 3, so this is going to be 3 pi. 3 pi is a quarter of the period, so if I add 3 pi to negative 2 pi, that'll give me this coordinate. So 3 pi minus 2 pi is pi. And then I add another 3 pi to get another of this quarter of the period. Or again, remember, this quarter of the period I could draw that a little bit better. That quarter of the period is 3 pi. So if I add 3 pi to 4 pi, I get 7 pi. And now I have all 5 of the x and y coordinates on this graph. Whoo, nice. That was number 5. On to number 6. Do I have enough room? Nah, I have infinite room, right? I have technology, so what do? I come here, I say add page, and then close, and then I scroll down. This was problem number 5. I'm on to problem number 6 out of 10. I know this is taking its sweet time. Number 6. We have minimum 0, -1. The minimum is 0, -1. The max is 10, 1. Max is 10, 1. So, graph those. I don't know why I'm feeling like having straight lines, but all of a sudden I do feel like having straight lines. So, graphing 0, -1, it's right about, oh, that's a minimum though. So let's go ahead and say this isn't the x-axis. Don't think about that. Let's think about that as the midline. That's the midline. So if this is the midline, the minimum and maximum are going to be equally spaced here and here, right? So I'm going to say 0, -1 is right about there. I'll call that 0, -1. And the maximum is 10, 1. I don't know, sure, right there. I've just chosen an arbitrary distance to the right. But this distance right here should be this distance right here. So it's going to be 10, 1. And then we know that the general function is going to go whoop. Wow, that's a terrible. Like, oh my God, Mr. Sindel, how have you not learned how to graph yet? I swear, it's this stylus. Drawing this electronically is way harder than drawing it physically. I think some of you that have a digital stylus at home know that. That's good enough. Maybe I can draw that point really big and say it's right there. All right, so notice that one full period is that total distance right here. This is one period, which means the 2 points that are given to us are half of a period. This distance right here is half of that. This is 1/2 of the period. So if I want to get to this x coordinate over here, which would be really nice because we have to find everything about this function, including the period, amplitude, blah, blah, blah. I want to know what is this. It's something, comma, -1. Why -1? Well, -1 is over here. It has to have the same height. What is that something? Well, if I've gone 10 for half the period, all I have to do is add on another half of the period to get to my final x coordinate. So if I've gone 10, go another 10. 10 plus 10 is 20. This x coordinate must be 20. And guess what? Oh, yes, I have to do that in a sec. This whole distance is 20, which means my period is 20. Yay! That is helpful. All right, so what starts at a minimum? Is it a sine function or a cosine function? And hopefully you have that in your notes. A cosine, but it has to be a negative cosine. So let's go ahead and start building our equation. Our equation looks like this. Y equals, it has to be negative some number cosine of, okay, and this is 100% of the time. Whenever you find the period, you're always going to do 2 pi divided by whatever that period is. Our period was 20, we put 20. And then we put in parentheses x. Was there any phase shift? No phase shift, so -0. Okay, I don't need to say -0. I'll just say x right there. X. Good. No phase shift. And then finally, what was our midline? We haven't figured that out either, so it's going to be plus some number. So we're missing 2 numbers, midline, and we're missing our number that affects amplitude. I guess this is amplitude now that we've dealt with the negative, so I'm being a little bit official about this. This is indeed the amplitude. So what is this distance? That will be the number that goes right there. See how I completed that arrow? Pretty fancy, huh? But I don't know what this y-coordinate is. So let's find that first. That's this, right? The midline. What is the y-coordinate of this midline? So notice this. If I've gone up 1 and down 1, that means I've gone a total distance of 2. This distance, I'm running out of room to write, but this distance right here is 2. If the full distance is 2, half of the distance must be 1. So this number is 1. And I'll go ahead and simplify this in a sec. I know I have to simplify. -1 is just really negative. 2 pi over 20 is really pi over 10. I'll simplify this down here. And then finally, what are you doing, Mr. Sindel? This distance is 1. Yes, we found amplitude first. And then if I go down 1 from 1, you get to 0. So it's something comma 0. This is also something comma 0. So our midline is 0. Why is it not writing right there? There it goes, 0. So simplifying this function for our final answer, y is equal to negative cosine of pi over 10x, the end. So many people are sending me emails. So popular, Mr. Sindel. That's number 6. Number 7. Number 7, sine of pi x. Y equals sine of pi x. All right, so there's only one number here, and it's the number that is affecting the period. So how do we figure out period? We've done it in problem number like 5 before. Yeah, 5, and it's this formula right here. Period is equal to 2 pi divided by whatever that number is. Recopy that down, and I'll do it in green again, sure, why not? Our period that we're going to be after is going to be 2 pi divided by whatever that number is, and in our case, this is going to be 2 pi divided by pi, because pi is that number that is the coefficient inside there. So 2 pi over pi, you might see, yep, pi and pi, those cancel out indeed, and you get 2. The whole period is 2. And that's the only change. It used to be 2 pi, and now it's 2. Everything else is the same. Amplitude is the same, midline, blah, 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 from our parent function. So let's go ahead and graph sine of pi x really quick. Normally sine, the parent function starts at 0, 0, and it still starts at 0, 0 because there's no phase shift. I'm not moving it left or right. And then we'll just go ahead and do a quick sketch. Boom. Not drawn to scale, of course. All of my graphs should have that notice on it. This whole period from here to here, that whole distance is 2. So if I add 2 to that 0, I get to 2. And guess what? My y-coordinate, my up and down movement, it's still 0. My up and down movement is typically 1. So I'm going to have something, comma, 1. And I'll have something, comma, 0. And I'll have something, comma, negative 1. I have all the y-coordinates. That hasn't changed. There's no number here or here to move that or stretch it or compress it. So next I have to figure out what is this x-coordinate? Well, this x-coordinate right here is going to be half of this total period of 2. Half of 2 is 1. And then how do I find this distance? Well, that x-coordinate is half of that total distance. That total distance is 1. Half of 1 is 1/2. So I know that a quarter of this period, 1/4 of this period, is 1/2. So I just have to add half, add a half, add a half. So you can say that this is 1.5, sure. Or you can say 3 halves if you want. You like fractions. It doesn't really matter, and we're done. On to number 8. This is where I know a lot of people were asking about this in class, so I'm guessing this is where you're trying to look at. And it is indeed a hard question. It is the hardest question that you can have going forwards, and then I have a really hard question going backwards. Here we go. We're going to graph y equals -5 cosine of, what was this, pi over 6, I think, pi over 6 minus pi over 2 minus pi over 2 plus 3. All of these together. All right, how do we even begin a problem like this? First of all, write it correctly, because this isn't in general form. You need to, oh, there's an x in here somewhere, wasn't there? Haha, I forgot the x in here, but there should have been an x. Sorry about that picture, everyone. There should be an x right there. That was corrected on the whiteboard. I forgot to take another picture, though. You have to factor out the number that's in front of the x. So how do you do that? You're going to say this is going to be y is equal to -5 still. Cosine and pi over 6 is going to be factored out, so you're left with just an x. And then this number right here is going to be pi over 2. That was the original number, but it needs to be divided by, that's what it means to factor out, divide by that pi over 6. Done-ish. I mean, you can simplify. Plus 3. So now it's time to do some scratch work. What is pi over 2 divided by pi over 6? Well, Mr. Sindel, that's just a keep it, change it, flip it. This is going to turn into pi over 2 times 6 over pi. And as you know, Mr. Sindel, a pi and pi will cancel each other out. You're going to go ahead and be really cool here and say 6 and 2 are going to cross cancel. You don't have to. You could just say 6 and 2, I guess. 6 divided by 2 is 3. So that number should be 3. So our actual equation, we're finally getting to it. Do I have enough room? Oh my gosh, I'm running low on room. I might have to copy and paste this onto another piece of paper. Our actual equation is y is equal to -5 cosine. Factored out, we have that pi over 6, which is going to be the number that affects the period, x minus 3. The minus sign will always be there. Like if it's there to begin with, it's there to end with. If this was a plus sign, you would change this to plus sign as well. So minus 3. Beautiful, plus 3. All right, we have all the components. Do I have enough room to squeeze in everything right here? I think so, because the only thing that's going to be kind of hard to find now is the period. How does this pi over 6 affect the period? And as I've said twice already in this video, the period here is equal to 2 pi divided by whatever that number is, and that number is 6, pi over 6. So this is going to be equal to 2 pi divided by pi over 6. I'm going to keep it, change it, flip it right now so I don't run out of room. This is going to be equal to 2 pi times 6 over pi. I know I skipped a few steps there. Hopefully you can follow that. That was a keep it, change it, flip it. And then from here, yes, the pi's do cancel out, and 2 times 6 is just 12. So the period here is 12. I'll say the period is equal to 12 after doing all that math. We know the period, we know the phase shift, we have all the components ready to go. So let's go ahead and graph the darn thing, right? Mr. Sindel, he said darn. All right, from here, first of all, am I going left or right 3? Minus, you'd think left, but it's always opposite. This is going right 3. So here's my normal function. Normally cosine would start right here, and then it would do something like that, right? Normally it starts at this maximum coordinate, but there's 2 things happening. First of all, it's negative, which means I come down here. Second of all, I'm going right 3, which means it's not here, it's, oh, let's say that distance was 3. I'm starting there, and then I do this sort of graph. I know, I'm terrible at drawing these functions. I'll get better. I promise. Come back in 10 years. You'll quiz me. So, what do we have right now? We know that this this used to be, well, let's back up. This is the midline. The midline is the easiest place to always start. The midline is 3. I'm going to say this is y is equal to 3. If this line is 3 and I go down 5, 3 minus 5 is negative 2. So I know that the y coordinate for this point is something comma negative 2. I know that this y coordinate, oh, and school just ended, it's 3:14. I know that this y coordinate is something comma 3. That's what it means to be on this midline. And then if I go up 5 from that 3, 5 plus 3 is 8. So this is going to be something comma 8. And then over here, this is going to be something comma 3 yet again. And then this is going to be something comma negative 2. Again, I'm just repeating these y coordinates that I have from over here. The y coordinates of all the minimums all should match, all the maximums should match, etc. I'm going to have to cut off the video and I'll be right back. Turns out I have 5 more minutes before we start. So what do you keep doing from here? We need to find the beginning x coordinate, this coordinate right here. And that is just the phase shift. It's 3. So that's nice and easy, 3. Then how do I figure out this end x coordinate? Well, it's 3 plus the period, and the period is 12, so 12 plus 3 is 15. These x coordinates are a little bit more difficult to find. This is half of the period. Half of the period is 12 divided by 2, so I can come over here and say half of the period is half of 12, which is 6. And I'll also have to find a quarter of the period. I might as well find that now. A quarter of the period is a quarter of 12, and a quarter of 12 is 3. Which means every single time that I move to the right to a new spot, I'm moving a quarter of the period. I'm moving 3. 3 plus 3, 6. 6 plus 3, 9. 9 plus 3, 12. 12 plus 3, 15. It all works out correct. And I have solved number 8. All right, time to jump into number 9. This one you're going backwards. The maximum is 10 pi negative 7. The minimum is 13 pi negative 13. Let's go ahead and graph those points. I'm just feeling like straight lines all of a sudden again. All right, so notice that both of these aren't even close to the y-axis. There's 10 pi, 13 pi, none of them are 0 like the previous problems. So I'm just going to randomly out here in space say, yeah, sure, maximum, that's above, minimum, that's below, and then I'll label these. So I'll say the maximum is 10 pi negative 7. The minimum over here is 13 pi negative 13. And then go ahead and make the graph. I always like going from the left to the right, but you could definitely go from the right to the left. So that's the maximum. It comes down here, hits the minimum, comes back up, and comes back to the maximum. All right, so we need to know a lot of things for this. This is a hard question because obviously there's phase shift. I've moved to the right, or maybe there isn't if you went all the way back. Maybe it hits the y-axis exactly for the maximum or minimum. But you generally want to be matching onto the general form for a sine or cosine function. I'm going to probably guess it's cosine since it's starting at a maximum, but you could have this as a sine function. If you say, hey, I'm going to start right there instead, sure. There's multiple ways to answer this. There's an infinite number of answers is another way of saying that. But the general form that we're trying to get to, if I come back to that, is a times I said cosine, a cosine of b being factored out of the x plus c plus d. So we need to figure out what every single one of these 4 variables is. And I've been doing that for the previous problems, even though some of the times we didn't need to find it. Oh, the amplitude is 1. We didn't really need to find a. This is a case where all of these do have a non-generic number. It is different than the parent function. How do we do this? So I think the first thing that's kind of popping out to me is the amplitude. So The y-coordinate here is -7, and I go all the way down here to -13. So how far is that distance? So this distance right here, whenever you're dealing with distance, it's always a subtraction problem. You take one number and you subtract the other number. It doesn't matter the order in which you do it. Just make sure that you're taking the absolute value of that, and you'll always get the correct answer. So I'm going to say -7, and then I go down minus a -13. There is a double negative here. So double negative means I'm really doing positive, so or plus -7 plus 13. And that's the same thing as 13 minus 7. You're allowed to rearrange these. So 13 minus 7, that's 6. So this whole distance here is 6. And remember, amplitude is only this distance right here. It's only half of that. And that distance is half, so it has to be 3. So we figured out that this number needs to be 3. Is it positive or negative? We haven't answered that, but we know that the absolute value is 3. That's just the amplitude. So let's start filling in our equation. We know it's 3. We can answer if it's positive or negative right now. I'm going to randomly say, let's start at that point. Again, you can start at any of these points and you'll get the right answer. So I'm randomly saying yes. Let's start at that point. If I start at that point, I'm starting at a maximum. Remember the difference between a positive cosine and a negative cosine. So a positive cosine function starts at a maximum and then comes back up to a maximum. A negative cosine function starts from a minimum and ends back at a minimum. They're just flipped over the midline. So I'm starting at a maximum. It's a positive cosine. This is a positive 3, and I just leave it as a 3. So 3 cosine. Whoa, I'm getting some weird lag. That was trippy. And then I have to figure out all this other stuff. So I'll leave this as x here, plus or minus something. I can figure out the midline right now. That's kind of easy to figure out. Well, I know if the distance here is 3 and I started at -7, if I go down an additional 3 units, I was already negative, I'm going to go negative even more. I get to what number? And you can also think of this as the average between -7 and a -13 is -10. This line right here is y equals -10. So my midline is not a plus, Mr. Sindel. This is a minus. Let's get rid of that. This should be a minus 10. We're halfway there, even more than halfway. We know our parent function. It's cosine. We know it's a positive 3. We know it's a -10. I just have to do kind of the harder bit here. So what should my phase shift be right here? Well, again, it depends on which point you chose. Remember, I kind of randomly decided on this point over here, but maybe I choose that point. Maybe I choose that point. Whatever point that you choose, you need to do the x number for that point. I have 10 pi, and then you need to flip it. If it was a negative 10 pi, make it positive 10 pi. If it is positive 10 pi, which it is in this case, you need to make it a minus 10 pi. And I know that's getting kind of squished in there, but I think you guys can read that. Perfect. Now we have one final piece, which is the period, the number that affects the period, I should say. This number by itself isn't just the period, because whatever this number, I'm going to call it b in this case, sure, why not? The period is 2 pi divided by whatever that b number is. So let's figure out what that b number should be. So what is the total distance between the point that I started with and this endpoint? Because that represents the period. I can say that this distance right here is the period. That is p. What is that? Well, notice that half of that distance, this distance right here, is half of the period. Half of the period from 10 pi to 13 pi, I've gone to the right 3 pi. If I go another right 3 pi, then I will get a full period, because that's another half of the period. So this must be another 3 pi to the right. Another 3 pi from 13 pi is 16 pi. So how far did I go? I went 3 pi and another 3 pi. The period for us, this p, I'm going to replace that with 6 pi. I've gone a total of 3 pi plus 3 pi units to the right from my starting point. That is my period, so I can say my period is 6 pi. And yes, you could go ahead and, okay, I need to figure out what that b value is. So the long way of doing it is this. You say, okay, it's equal to 2 pi over b, and then you can say that's over 1, and then you can cross multiply and do some things. There's that cool little shortcut where you're allowed to switch diagonals. You can say b over 1 is equal to 2 pi over 6 pi, and done. We have the period. The period, or not period, this is the value of b. This value of b is 2 pi over 6 pi, which does reduce down. The pi's and pi's do cancel out. 2 divided by 6 is 1 over 3. This number should be 1/3. But Mr. Sindel, you said that was a long way of doing it. What's the shortcut? The answer is whatever your period is, we know our period is 6 pi, whatever your period is, you're always going to make this number 2 pi divided by the period. That's our little shortcut. In this case, it was just going to be 2 pi over the period of 6 pi, and you do all of this same math to simplify that into 1/3. Either way, you do get 1/3 here. We have our final answer. There it is, 3 cosine 1/3, quantity of x minus, I know that's 10 pi, it's kind of hard to see, minus 10. We're not done though. That was problem number 9, and there was problem number 10, which is just a bunch of really tiny problems. So 10, I told you to evaluate for the following problems. So what was the first problem? The first problem, ooh, that's something else, is cosine of pi over 2. So cosine of pi over 2. So the way that you think of these in your head, this is what I think of. Pi over 2, first you have to know where that is. Boom, it's right there. Cosine is that the x or the y coordinate. That's the x coordinate, not the y coordinate. Y coordinate is sine. What is the x coordinate of that point? It's 0. How much left or right did you move off of this y-axis? You didn't. You didn't. B, that's going to be sine of 3 pi over 2. Sine of 3 pi over 2. Where is 3 pi over 2? It's right there. Sine is the y-coordinate. The y-coordinate of that is -1. Again, this is just from our speed sheet for trig values of special angles. So if you don't know those, there is a quiz that's still up on Google Classroom. You can still learn those. C, cosine of 2 pi over 3. Cosine of 2 pi over 3. Where is 2 pi over 3? It's right there. Cosine is the x-coordinate. I went left a little amount. The littlest one that we have is 1/2, so it's -1/2. D, sine of 5 pi over 6. Sine of 5 pi over 6. That is a 5. First, you have to ask yourself, where is sine of 5, or where is 5 pi over 6? It's right here. Sine is the y-coordinate. Notice I've moved up a little amount. Our littlest amount is 1/2. Again, the way that I think about this, I think of little as 1/2. I think of a medium amount as √2 over 2, and I think of a big amount as that's supposed to be √3 over 2. So whenever I say big, medium, small, those numbers are correlated over there. What about E? I think I can squeeze in E over here. E is cosine 3 pi over 4. Cosine of 3 pi over 4. So first you have to ask yourself, where is 3 pi over 4? And boom, it's right there. I meant to undo, not to alt-tab. So up here I have a medium amount that I'm moving to the left. By the way, this is the x-coordinate because I'm talking about cosine, so I'm talking about left and right. I've moved left a medium amount. Moving left a large amount would have been right there. Moving left a small amount would have been right there. This is left a medium amount, and a medium amount is √2 over 2. So the answer is negative, because I've gone left, not right, negative √2 over 2. What about F? F is sine of 11 pi over 6. Sine of 11 pi over 6. So again, you have to ask yourself the question, where is 11 pi over 6? And it's right there. Sine is asking for the y-coordinate. Notice I've moved down a small amount. This is -1/2. And finally, the last question on this entire pretest, cosine of 5 pi over 4. Cosine of 5 pi over 4. Where is 5 pi over 4? Oop, that line should have gone over there. 5 pi over 4 lives right here. Cosine is the x-coordinate. How much to the left did you move? You moved left a medium amount. That is left √2 over 2. And that is the final answer for our practice test. Going brain dead here. There is that, if you need to screenshot it for whatever reason, there is the first piece of that, and that concludes Algebra 2 Pretest 9 from 2021.